Hello and good morning. My name is Muhammad Chan Farhan bin Shahruddin, and I will be explaining on the introduction part. The first point of our project is to find the crucial roles of signal processing, which is in various technical systems, which we can see in very continuous advance in methods and technique, and also it explores the fundamental principle of both analog and digital signal processing, such as calculus, complexing number, and background differential equation. So the second point is the Fourier series and periodic signal decomposition. So it will explain the mathematical and visual proof of how Fourier series can represent any periodic signal as an infinite sum of the sine wave, and allowing them to be comprehend periodic signals uh, as combination of different frequency component. The third part of the this project is to uh, know the uses of Fourier series, amplitude, phase trigonometric, and complex exponential, and using to know their utility in various fields such as signal processing fields in signals.
Assalamualaikum. My name is Ahmad Asman Dika. My metric number is CE2100 and 11. For group project, I will present the methodology of our report. For methodology in understanding Fourier series, particularly in its exponential form, we explore a simplified approach for describing period signal, utilizing complex exponential function to simulate the signal. The representation involves expressing a signal as a sum of complex exponential terms with distinct frequencies and complex coefficients. The core equation takes the form and where integration compute the dot product of the signal and the complex exponential function over the signal period is t. The exponential form offers several advantages. Firstly, it provides concise representation of frequency domain analysis, enabling the decomposition of signal to reveal its spectral characteristic. Next is application in signal processing, telecommunications, and compression benefit significantly from this approach. The complex coefficient encode both amplitude and phase information of each frequency component, following allowing for efficient manipulation and analysis. Determining this coefficient can be achieved through various methods depending on the signal's complexity and available resources. In summary, the exponential form of a sorry, Fourier series serves as a powerful mathematical tool for decoding and visualizing period signal, finding application in diverse fields such as engineering, physics, and applied mathematics, where the encode complex coefficient provide value insight into the magnitude and phase. That's all from me. Thank you.
Okay, so in addition, right, before we start the simulation with the value from the workspace, let's start with the generator first to test the RC filter system. Okay, so we set the signal generator, the amplitude and the frequency randomly. So for the frequency we can set at 900k before our group time is using 900k. So okay, now let's try run it. Okay, so this the left one is before filter, the right one is the waveform filter with RC circuit. Okay. Hi guys, I'm Valentin Teo Jinglong and my metric number is C210010 and I'm from group 9. So today I'll present about the simulation of ST to Simulink, and then X omega to Simulink. So let's start with the ST first. As you can see that this is our coding, right? So our group 9 is using the fundamental frequency for 150k, and then the cutoff frequency is around 900k kilohertz. So let's try to run this circuit at first. I mean this coding. Okay, let's wait for a while. So you can see that this is the waveform of before filter and this is after filter. Okay, now once we got the value at workspace, we'll move to the Simulink. So okay, before we start to run it, right, I would like to show you that this is our RC circuit that filter the signal. So the R value is set at 10k ohm and the capacitor value is set at 35 millifarad. Okay, let's move back to it. So we set the stop time at 10,000. Okay, now let's try run it. So it take a while, still loading. Okay, so this is our waveform. This is before filter and this is after filter. Okay, now we'll move to the next part. Let's comment out this circuit as first, because I got another circuit at here which is S omega. Comment. Okay, now let's move back to MATLAB. Okay, so this is our circuit for the S omega. So the fundamental frequency is still remain the same, and then let's try run the section. Okay, it takes a while to run it. Okay, after it's done, the workspace has been refreshed also, and then this is the figure of the STN. So now let's move back to the Simulink. Okay, it will retake the value from the maplet. Now let's try run it. Okay, you can see that. So this is the waveform of uh, without the RC filter, and this is the waveform with RC filter. Okay, I think that's all for me. Thank you.
Hello, my name is Edwin Sandai. I'm a metric card AC21010. So next, I was going to explain for coding for our subject. This is our coding for the low pass filter. So this project we're going to design about three harmonics and get the output result. So for the coding one, the given the value the given to us is 150 kilohertz for F no, and then for the FC we give what's given 900 kilohertz. So this is the coding for the low pass filter three harmonics. As you can see, this for the filter signal with 5 harmonic coding. And then for the second one is the filter signal with 10 harmonics. The last one is for 20 harmonics. So I'm going to run it. Yeah. So this is the frequency that we get for the XT. As you can see, this is without the filter, and then the other one is the with filter. This is our XT. Next, for the coding frequency domain. For the frequency domain, we use the same value 150 kilohertz and 900 kilohertz with other third harmonic coding. So I'm going to run it. So this is the result that I get. So for the frequency domain, for SW, so this is the of wave that we get, and then the other one is for the filter one. This is the result that we get, and then for the tau part, so we was assigned to use 10, 20, 30, and 70, 80 value. So this one we going to get 10% tau. Uh, as you can see, this is the result that we get. And then for the next one is so I'm going to change it to 2, so 20%. So I'm going to run it. So this is the result that I get. As you can see here. And then for the one is 30%. So this is the sum of signal that we get for the 30% tau. And then the next one is a 70%. So this is the result that we get for the 70% of tau. And then the last one is 80%. So this is the result last one for the 80% for the tau. Then the last one is the our frequency response. So we were given 900 kilohertz. So I'm going to run it. This is the formula that were given 20 multiplied with log. So also this is the frequency graph, the gain versus frequency. As you can see here, this is frequency response going down. So that's all from me. Thank you.
Okay, my name is Muhammad Isha Akimi bin Muhammad Radwan. My metric number is CE220041 and I am from group 9. I will explain about question 1B, annual population. So, for 1B, we need to find the impulse response HD based on the given root, which is 1, -2, and -3. Okay, this is the manual population. First, we need to uh, replace the s3 plus 4s square plus s minus 6 with the root given, and then we split it equal to a over s negative 1 because it's the given root is positive 1 plus b over s plus 2 plus c over s plus 3, and then we multiply um, For A, we multiply with s plus 2 and s plus 3. For B, we multiply with s minus 1 and s plus 3. For C, we multiply with s minus 1 and s plus 2. So, this is the for the first equation is 4a plus b minus equal to minus 3, first equation. And then from the first equation, we get 7a minus 1c equal to negative 10, which is equation 2. From the equation 1 and 2, we replace to get the value of a, b, and c. And for the a, we get negative 1, b 1, and c equal to negative 3. And then this is the hs. We replace the value a with negative 1, b 1, and negative 3 is c from this equation. After that, we look for the Fourier transform table to get the analysis impulse HT. That's all from me. Thank you.
Okay, on the conclusion part is we know that we perform after several tests. It was concluded that the Fourier series provide the most effective approach to analyzing and solving XT. And then we observed that the amplitude of the signal increase with harmonic number, emphasize the role of harmonics as a representation of sinusoidal components with non-sinusoidal waveform, and the relationship is increase in amplitude of the sinusoidal of xt, and this explains the parameter of n and reflects the accuracy of non-sinusoidal waveform. So this shows us the significant role of signal analysis, and especially in Fourier series. Right, thank you.